And we're back. Hopefully. Just tweet it and we can keep going. So I installed the oldest available nightly, and unfortunately that also had problems. So then I installed, what is it, 5.1 stable. And I guess I will just keep monitoring 5.1.2. I'll just keep monitoring the nightlies and see when they fix stuff. But yeah, I tested a few things and it seems to be working fine. And even see here now, it actually aligns where it should. So strange. I have no idea what is happening in those nightlies there. So can fix up quickly these annoying issues right here. See, like I can actually align it and everything aligns where it should. There we go. So I can actually just do, so what I did in the meanwhile while it was installing, I opened this schematic. This is Adafruit's 2.4-inch LCD feather wing. You can see it here. So I'm gonna copy a few things from here because I think, I mean, this is their official one, so this is the way they want it done. But also quite a few things here are the way I was gonna do it anyway. So yeah, like I will need to have SMD headers for sure, because on the other side of those, it's the keyboard and the LCD, and you can't have pins sticking through those. I want to have double, so even if you mount the feather in, you still have access to all the GPIOs, even though you can also stack them. So you will have two ways to do it. So that's good. Then I will reuse the GPIOs that they use for CS, NDC pins here. So that way the libraries made for this should also just work on my board. And I did a quick read up on the spec of the feathers. So the enable pin, turns it on and off as obviously. So I think adding a switch on the board will also be good, so you can just turn it off and then no battery being drained at all. You don't need any proper shutdown logic. You can just turn it off. And lastly, I think, I mean, it's not based on this board. I also wanted to add it before. I want to add a SD card, so you can put your images or like data or whatever you need on the SD card, and then load it. And since there's already a defined pin out for that, perfect. Let's just go for that. So what I have here is I have the schematic for that wing, and we can copy a few things. I see they have a nice symbol here, and they actually put the numbers here the way they are on the whichever wing it was whatever feather, like here 1312. Even though the one I have here, the ESP32, has different numbers, but yeah, oh well, I can use those. It doesn't matter. You will be able to put whatever you really feel like there anyway. But yes, so hopefully we can, oops, that's not right. That should be here. Hopefully we can get back to sanity and no crashing, no embarrassments on stream. So what we can do here actually is add these GPIOs over here. So we have GPIO 9. Let's, oops. Right, and I also listened to the stream, the one I just did before this one, and I noticed the keyboard sound is quite loud. So I'm gonna try to type a bit more, like not as hard, so it doesn't just clickety-clack in your ears. And this isn't even a mechanical keyboard. This is like a standard rubber dome, so I don't know why it's so loud. I guess maybe I set the microphone settings too high. Okay, so I decided also while offline that I will actually create the keyboard's sheet manually, just because I think there's some educational value there and it shouldn't take that long, so we can get into that. And I also already preloaded the symbols and the modules, so hopefully it won't kill the stream when I get to that point. It obviously won't work in this instance of Kicad, but I won't be adding anything here, so we should be fine. So there's the keyboard, and let's again start with the buttons. Hopefully it goes nice and smooth this time around. But I can already see that the things that were broken in the nightly are working here. So see, like as soon as I press W, it actually starts the trace, and as soon as I press A, it opens the dialog, which was not the case in the nightly. So that was quite annoying because it was throwing me off. Like, this is not how it used to be, and muscle memory is, it's a real thing. So it was, yeah, really annoying. Yeah, but I hope we can get through this pretty quickly. See, so I don't know if they changed it I mean, they had to change it in nightly because it was Control D in the nightly and here it's C. So that's, again, my muscle memory was smarter than my, I don't know, brain memory, something like that. And then we have the left, and we have to rename this as well. Left, there we go. Sorry, like I said I will type lighter, but I did not again. Hit it quite hard. Then, yeah, there's no way around it. I have to start copying also these libraries. Like, this is my my custom library over here with the 5-way. I don't think they added it. I can check, but seems unlikely. Can have just a quick look in the switch library. I mean, I could use like this, but it's not as nice. Yeah, it doesn't look like, no. Okay, so what we do here is I go into the library, and then we have the lib, and I copy it. Okay, I don't have it open. I go to the Handheld repository. Hopefully people see the link to the new stream on Twitter and they care enough to join again. Although I wouldn't blame them if they're discouraged by the previous experience, but so far smooth sailing. So I need to add the library I just copied, so let's get to that. Let's do that. There we go. And then we add this 5-way switch. There it is. Did they make the default font larger? That's interesting. You can see here text size 0.5 inch, and here, no, that's the same, but looks okay. It was just the zoom level. Okay, it's shifted by like there. Doesn't really matter. So here we can also quickly copy this. Here we go, align the grounds, and Joystick app. Down, left, right, and center. There we go. So that takes care of this one. Then the Blackberry Keyboard, that's a separate library. And I think I'm switching between pronouncing library and library. There it is. Okay, we have the keyboard to add it here again. It's gonna be a slight problem if I already have a library here that I need to just add a part into, but let's not worry about that for now. So now I should be able to add the BBQ Q10. Yes. What the heck just happened? Wow, seriously? What? That makes so little sense. Wow. Kicad is really... And now it works. Okay, now that's... I have no idea. Why would that happen on a quote stable release? Maybe not so stable after all. But let's not get discouraged by that. I checked before the stream and the insert functionality seems to work, so this should go really fast. There we go. And there. Then we have the grounds. Can copy here. And again, for the mic and mic VDD, let's for now add a test point for it. Test point. Let's say TP. No, test. Oh, I'm adding power symbols, that's why. So or actually TP mic, and I can hide this. That's the wrong way around. I think this was fixed actually in the nightly, because I mean it was to the right, but since this is rotated 180, it assumes the other way, which is definitely strange. Yeah. So actually, let's put it on. I don't know if I need a MOSFET, because the logic here is that, I mean, even if the mic is not in use, like we're not reading it, it is powered, so it's gonna draw some current, and you might not want that. So actually, you know what? Yeah. I'm gonna make it flexible. So I will add a solder jumper, is it called here, or is it a bridge? Is it called it? Yeah, exactly, but it's gonna be open. So if someone wants to enable them, use the mic, they can, but they have to solder this one, and that should solder jumper, no, solder bridge, mic, or actually mic VDD. Yes, so they can do it, but they have to solder here. I think that's a fair thing to do. We can actually do this. Oh no. Oh yeah. My bad. I thought this was after the jumper, but this works. So here it will always be 3 volt, and then here we go into a MOSFET and we will have control over the backlight. Yeah, the BSS 138 is quite common and I find it very, like, it works in most cases when you need a simple no-side MOSFET. I mean, no magic there, it's just a MOSFET and channel. So we need the pull down, so by default it's off, as says here, and I will copy this comment as well. Keyboard backlight control. Actually, it's just backlight because I would add a keyboard. Actually, yeah, I would add a prefix if it's going out of the sheet, but this is just connects to the SAM, so we don't need that. Quality is good. Thank you, Anu. I'm quite happy. It's silly because right now the microphone I'm using is an old webcam that I found, and it seems the microphone on this webcam is actually the best microphone I have. Even this one I bought specially for this is not as good. I think it's really clear audio thanks to this webcam. And on the previous stream, not today, like the other day, I was trying a different webcam, this PS2 or PS3i, yeah, the PlayStation i, and that one also seems better than the streaming mic I got, but this is even better. So I think I'm fairly happy with this one, which is strange. So here we are, then we can add, so backlight active. See, on Windows control backspace doesn't work, and I'm so used to it on Linux. So the backlight is off by default. You have to pull the control high. I mean, the MOSFET, the gate is active high. So, but as I mentioned, this MOSFET allows us also to PWM the backlight, so we can have control over the brightness. It's not just 100% blinding light. Right, so here we're done with this part. Yeah, I was gonna say so far 0 crashes, but I shouldn't tempt Kicad. Again, so this symbol I added also because for whatever reason, when I was creating this like a year ago at least, Kicad didn't have any SAMD chips, and let's see if that has changed. 20, nope, I believe it's possible that 21 is actually compatible with the 20, or yeah. But to be honest, let's see, ground is on 10. Kinda looks compatible, but I'm quite happy with this, just the way the symbol is done, like it's designed specifically for this. So I'm just gonna copy it, except one thing. I think I have to rename it because there already is a standard library called like this. Yeah, back when I created it, it wasn't there, but now it is there. So I'll need to rename it. Not a problem at all. Yeah, that's good enough for Kicad to know that it's renamed. So we add it. Hopefully no strangeness will happen again now when I add this, but who knows. So D20E, that should be enough. See, what the heck? But if I undo, nope. Let's go out and go back in, and I think it will crash. Nope. Okay, just some drawing issue. And this is stable. Let's keep positive. It's at least not crashing so far. It's not. At least the basic functionality works. This is the level we're at. It can work 5 minutes without crashing, and it's a good day. So, like I mentioned, no, not this one. Like I mentioned, I would like to add 2 more buttons, to have 4 buttons like on the sides of the joystick. It would, I think, be nice, but the problem here is I'm out of GPIOs actually. As you can see, I have 1 and I need 2. So not much I can do. I think these come also in higher pin, but then obviously the price is gonna go up. Let's do it for now with this. I might look into changing it later, but let's see. So what I'm doing here now is I'm copying all the signals that I want going into this one, and this will allow me to connect them a lot faster than if I were creating labels and typing. This will save me a lot of time. And now you might, as I do this, you might wonder why is, like, what's the logic behind this connections? Like, why isn't it just 1, 2, 3, 4, 5? And it is a bit, but not perfectly. And the reason is routing. So the way the keyboard connects to the chip and the pins are laid out on the chip, this connections allows super easy routing into the keyboard. Like I don't have to do vias on top of vias and sweat it. And since I control the code, it does not matter what is connected where, except the SD, the I2C stuff. These 2 pins, those are the only ones that matter. So yeah, just go for this, and it's tested. I did this like a year ago almost, and it's been working since then. So no problem. And then the keyboard backlight. And then we have 1 and 1. 2 and 2. And then, did I forget 1 column? No, it's there. Alright, I know what I did. I forgot the I2C stuff, which is, yes, and that is perfect then. So we have SDA, we have the clock, and we have the interrupt, which I'm not sure will be used, but let's have it. And then I need to, alright, that was wrong. It has to be, I can actually, because it has to be a sheet label, so it's available outside. And this is still I consider this a bug in Kicad, that it does not preserve the rotation when you change the label types. Then yes, I changed the shape, but the shape also defines, I believe, the type, and it makes sense later during ERC to actually have it the proper way. Okay, so then we connect the power here. This is so much easier when I'm just copying, but we'll get to the actual creative parts eventually. I mean, for me, it's not new, but for the people who might watch this, it is new, so I think there is value here. That's not right. So you might be asking, if you're new to PCB design or electronics, where do these values come from? Like, how do you know how many caps to add and what values they should have, and like how do you do? So the answer is boring and simple, and it's from the datasheet. You have to read the datasheet for this chip, and it will tell you exactly how many, like most datasheets for these microcontrollers will, and CPUs also, will tell you how many caps and what values you should have for each pin. That's kind of it. And they will also tell you that they should be as close as possible physically to the chip. And that's the boring answer, but it's the true answer. Okay, then we have the programming interface here. And we need a pull. Not all microcontrollers require a pull on the clock. And again, this comes from the datasheet. They say you need a pull up, and I think they even specify 1K, which I see I put wrong, on the clock for the debugging interface to work correctly. So you need to read those datasheets, and you need to follow them. Right, so the reset pin here was high because I didn't need to reset, and there is a software reset, but I think actually what I might do, since the feathers, they all have a reset button and there's a reset pin, I might actually connect it here. That will allow us to reset this chip also when the whole board is reset, and that just gives us a known state, which is always good to have. So let's have a reset, but let's have it. To answer your question, I don't calculate values. No, not here, not right now. There is sometimes that you have to do it, like when you do a voltage divider, or yeah, even not really for LEDs. Like LEDs need resistor, but you kind of find a good value that works for you and you use it, like, because it depends on what brightness you want. So there's actually not that much math in my experience working with these digital interfaces. There's definitely more if you were to work with analog stuff, all the RF magic, but not here, not right now. So here we have the keyboard stuff. There we go. See, this is, I know I complain a lot on these streams. Like, this is really bad UI design. Like, there is more buttons there, see them? And in most Windows, in most programs, when this happens, when there's more icons than the toolbar allows, you get this drop icon here and then you get the rest, but not in Kicad. So you have to now go and look where those are here in the menus, and there used to be in the older versions that those buttons, those functions were actually only in the toolbar. So if you had a low resolution, you were screwed. Actually, this is wrong. Clock is misleading. Yep. Correct. Reset. Ground. We're missing, no? Okay, so that's this part. And then, again, as I mentioned on the previous stream, this microcontroller has a TX, has a UART, I believe, on these two pins, and I mark it here as TX, so we can actually, if we need to debug the firmware running on it, you can just solder here and get a UART. Then you have to disconnect the keyboard, or no, actually you have to do it in the code. You have to change this to be a UART functionality. So I will preserve this here with a test point because I think I will have a lot of space on that board. So test points all around. There we go, and this is PA22. Copy this one, we put a test point on it. Not a label, a test point, so I copy again. I hope this copying doesn't screw me over because something might get preserved. TX. All right, and then we need pull-up on I2C since it seems the feathers don't have those. But I'm thinking if this should be here or one level up in the main. Here it made sense to have it here, but you know what? Yeah, let's put them higher. Seems more relevant there. Right. So this is it for this one. Now we have this sheet, and I made these sheet labels inside it. Now I can pull them out by doing this here. So we have the data, we have the clock, and then we have the interrupt, which should be more like this. I like to keep them so inputs are on left and outputs are on the right. So then I can make it nice, small like this. We have the keyboard, clock, keyboard data, and keyboard interrupt. Perfect. Now, what we can do here is actually add these. Let's see. Right, so I want a switch on the enable. We can do that at one point. Interesting that they put the VBAT to 5 volt, even though that can go as low as 3.7. I guess it just means higher voltage than 3.3. Yeah, the reset button external, we don't need that. So, all right, that should be a reset also, isn't there? Did I forget to? Yes, I forgot to convert this to. There you go. Now I can import it. And trying to adjust the labels, but it's not allowing me to. just wanted to do this. So we have the keyboard reset. Yes, indeed. So we have the main reset, and that connects into the keyboard reset. It will also connect to the LCD reset. And then, let's see. See, I'm not sure if I'm happy with the way they have it here, because it's just readability, really. Let's try it. Let's try the way I would do it, and we can go back to this if it's better. But we have pin 5. And then we need that solder bridge thing. Actually, we want it closed because we want the SD card to be enabled by default, and then someone can cut it if they need it. There you go. So this is the card CS. Fine. What is this? This is solder card CS. And now I just want to verify that is it consistent with, yeah, I said SB and this is SB. All right. So we have this connecting there. Then we also have the TFT-DC and TFT-CS. So the CS is on 9. Let's verify pin on GPIO 9 is TFT-CS, correct, and DC is on 10. We have the LCD DC, which is the data or command selection input. So like if it's high, you're sending commands, and if it's low, it's data, or the other way around. I don't remember, and it doesn't matter. Right, so see, like this is how I would do it. I would keep it to the side, and this is its own entity, and here you have the bridges, and the resets are just like this tree of what connects to the reset, and there will be also LCD reset here for sure. Just getting a bit ahead of myself. And you know what? We can add the switch. Should it be? Should be 3 pins, isn't it? Actually, no, it's not, because it just either connects or it doesn't. Push. That's the one. Yes. Such a fancy symbol. So this is switch enable. So here we have the enable. And if it's pulled to the ground, then it's off, if I understand correctly. So if it's floating, there's a pull-up probably on it. We can actually check it. I think that's how it is, that it's enabled by default, and there's a pull-up, so you don't need to worry about that. And then if you want to turn it off, you just do, yeah. There you go, exactly. So there's a pull-up, and that will disable the power, while still being able to charge the battery, I believe. So by default, it's nothing, and we can connect it to ground. Yes. So let's put it just here to the side. Let's put everything here. There's the keyboard. Can I see the keyboard here? So we could actually do... I got distracted because I saw the SPI flash here, and this is a quad SPI flash actually, but the feathers don't really have quad SPI, because it would be cool to also have it on this board. There is space. I mean, it adds to the bomb, but you don't have to mount it, so it can still be cheap and optional. But since there's no quad SPI, I could have just a SPI flash. I might look into it later if there are feathers or wings that actually have SPI flash. And if someone in the chat knows, link it to me and then I can check it out now. So we can go for the SD card because, as you can see, it's also really simple here. I'm starting to worry because these feathers have so few pins, and if I want the detection, and I would like the detection, then I'm gonna run out of, like, users will have no pins whatsoever. See, like, they don't use the detection, but wouldn't, no, that's there. Where is it actually? That's the backlight. That's a bit strange. So they add a label to it, but it's not connected to anything. Yeah, I would probably connect to something. Or maybe, yeah, again, make it optional, make everything optional. Freedom of choice. Yeah. If you're wondering why I didn't add these pull-ups, it's because I will add them next to the actual parts and not here. Actually, you usually don't put pull-ups on CS, like you just do it in software. Or maybe it makes sense if you were not gonna use them. Yeah, I guess so. If I used Eagle, I could just take these symbols here or even open this and copy half of it. But my Eagle days are behind me, and I'm really happy about Kicad actually. When I'm not using a nightly that crashes every 3 minutes. Yes, I am a bit salty. So the symbol here is microSD card detect. It's kind of silly. This, like, some of the symbols are really strange. Like, I kind of get why you would want this drawing of an SD card here, but also I don't. Not quite. Because, I mean, just have a minimal tiny symbol and be happy. It's also a bit actually annoying that this is in the order that's on the SD card and not proper. Like ground should be on the bottom, power on the top. Otherwise you get these strange situations going on here. And I could spin my own, but who has the time? Yeah, so these two detect pins, in case you don't know, the way it works is when the card is inserted, they are shorted. That's it. So whatever you connect to B, you will get on A when you insert the card. Otherwise, it's just floating. That's all there is to it. And I actually like the prefix card, so I'm gonna change it there. No, actually, I switched way back. Just someone showed me Kicad, and I tried it a bit, and I liked it way more than Eagle. Just I don't know if it changed, but when I was using Eagle, there was no real shortcuts. Like there's this terminal where you can type commands, but like just notice how little I actually click the toolbars in Kicad. Everything is in shortcuts, and that allows me for a very just rapid, just speed of CADing is unparalleled. See, like I don't like this. I would create my own. Right, Eagle. Yeah, right, because it's Autodesk now, so it can work with Fusion and all those cool Autodesk programs. That is cool. I can admit that for sure. Oh, there's a shield here. So Timon, it's not Timon, no, it's Timon. You've been on the previous stream. How is the audio quality compared to the previous one? Okay, there was no default shortcuts. I never really bothered to look. I just know I had to click something, do it, something, and do it again, and then. And also it was limited to I think 2 layers. The size was like maximum 10 by 10 possibly. I don't know if that changed since then, but this just gave me new amount of power. So the CS here, we rename it. Perfect. This actually probably doesn't have to be its own sheet. It would fit all on one, but it makes more sense to do it like that. So this is a Wi-Fi. We don't use that. The SPI, I'll get back to that. It's a bit low volume. Okay, because I did actually like in OBS you have this green and what's it called? I don't know, like spectrum, green, yellow, red, and I was getting into the reds, so I lowered the volume. I could increase it, but maybe I shouldn't do that in the middle of the stream because then, yeah. So we don't need NRF, we don't need the P mods, we don't need the USB, which is, I'm a bit on the fence on that because I really liked having the USB on the bottom, so like it feels natural to connect a connector in this handheld on the bottom or on the top, just not like in the back. And this will force you to do it on the back because that's where the feather is. I wish there was feathers that, like if you look at the, let me just tangent here for a second, the NRF52 840, the dongle, if you look at this one, what they actually have is there is a back, yeah, here. They actually have, oh, this is tiny. They have pads for USB. So you could actually hack kind of, like if you were to mount this into another board, you could connect to these with pogo pins and then route them somewhere else. And that, if Feathers had that, that would be really nice. So if they had the data pins from the USB on the back as test pads, test points, you could just route them somewhere else. But I think my use case here is really specific to me. I don't think I haven't seen any wing other like similar to mine. They usually are the same shape as the feathers, so they just go on top or on the bottom. There is that LCD one, the one I'm using right now, and that's slightly similar, but yeah. I guess there is, someone was making like a, I don't know what it's called, something boy probably, because it's a game console where you just plugged, oh yeah, it was Grogard, yeah, with his Linux feather, the giant board. So he made like a display plus joystick and buttons, wing, and you would just put the feather in the back and then you would get a handheld console. So that's a bit similar. Oh, the NRF feather has, interesting actually. Well, now I have to check it. So now the stream is just derailed. No, it won't be on 52, right? It will be on the, oh yeah, yes. Thank you for the link. See, now this is what I'm talking about. They, maybe in the future all their feathers will actually have this. I mean, this is really good. This would be perfect. Oh well. Thanks for Googling that for me. It would be, I don't have to then do it on stream. So we have the keyboard. We have battery stuff. We don't need this because the feathers have the charging. See, like it's so nice with the feather. It will take care of so much for me. And then the LCD is also really simple here. But that's it. I just have the footprint and some stuff. So let's do that one. So I will also create a sheet for this one. Then I know I need the library for this, which is this one. Oh, so we're actually now in the situation that I described. I already have this library, but I'm gonna go the hacky way. I'm just gonna paste it like this instead of doing it in Kicad. I think this is faster actually. So if I open this, just paste it at the end. It should work, or it will crash Kicad. One of those. Let's see. All right, I need to add it first. So that's an added bonus that it wasn't aware of the library before, so maybe it won't crash. Let me just get them in alphabetical order for absolutely no reason, only to, because I like it that way. It was TRF, wasn't it? TF? There it is. So, right, because I did two versions of these boards. One was with the connector on the bottom and one on the connector on the top, like under the display. And the reason for that was because of the PMOD connectors. I was actually running out of space on the back. If the connector for the LCD was there, it's quite a big one. It's like 50, yeah, it's 50 pins. So it was beneficial to have it on the back, on the front under the display. But it was annoying because the display was then not flat on the board. And I think here I could actually do it again the way it was before, because because I don't need it. Yeah, because I don't need so much space on the back. Let's do that, and hopefully I won't screw it. Now you can see it's different, because if it's on the front as opposed to the back, then the flex is reversed 180 and all the pins, like 1 becomes 50 and all that. So later I can double check, like this is a Git repo, so I can easily check out an older revision and double check that I did the connections correctly. But for now, let's just connect the way this is. I don't think it should be a problem. Look at all these grounds here. Oops, off by 1 error. How interesting. How did I manage to screw that up? You know what, let's fix this. There you go. Can I keep inserting? Nope. Oh. Okay. Oh, it broke. But actually, I've seen this happen before, so I think, nope. I thought if I went out of the sheet and back, that would fix it, but this should fix it, I believe. Yeah. Oh, so the ground is also 1 off. So let's go out. And change it here. And I have to move this, and I have to move this. But it's worth it because it's aligned. Yes, and now I think it should still work because I exited the sheet. These are the easy ones. I'm really torn if I need the pull-ups on the CS. I usually don't do it, but it's because I was using all the peripherals on the board, because it was my board that I knew exactly what to use for. But maybe we need a CS in case someone doesn't initialize the GPIOs. Yeah, let's do that. So let's start here. I type faster than the window can open. Right, and here there's the touchpad, touch screen pins, and this display I'm using, excuse me, the display I'm using comes with either no touch panel, or a capacitive or a resistive. And I think for the capacitive, these become I2C pins, I believe. But I haven't used any of them. Maybe it's worth bringing them out. what about, right, the one used in the wing here, they have like a separate chip for that, right? Yeah, exactly. So this is a touch SPI controller. Maybe that actually would be good to use. Yeah. Again, optional if you want an LCD that has no touch, just skip the whole thing. Not 100% sure about this. Like, what is this LCD light? It's connected to the enable. Is it? It can't be the backlight control because that's here. Right. Oh. Okay, I think I. So this is a shutdown pin for this chip, but they called the whole net light. Which is, they should have called it like enable or something. You know what? Let's STMPE11. I'm curious how much it costs. And you might say this is not Kicad stream, but I challenge you saying this is part of the process. So you're just getting the real experience. 190 euros. That's quite alright, I guess, if it's optional. Port expander. I thought it was touch. I might have to read up more on that wing. With touchscreen. Yes, okay. Cool, that would be really nice actually if I reuse that. Yeah, exactly. You're getting the genuine experience. Don't complain. Theoretical person that doesn't exist. Where were we? Here. Do the parts. I actually never really tested the Mouser parts. I just usually just make my own because there's a specific way I like them. So I'm not sure actually. See, again, I should have went for the sheet labels. There is a button here for that. It's just so much easier to press L. I don't think there's a... Okay, I have no excuse. There is a shortcut for it, although it's not very friendly. Is it Shift S? Who makes shortcuts with Shift? All of them are with Shift. Okay, that doesn't even make sense because... Right, so it's just H. Shift is just... No, creating symbols in Kicad, it's actually really fast. Footprints is a bit longer because it's more technical drawing, but symbols, I quite enjoy it. Like I spoke a lot about it in my previous streams, that I find creating symbols very zen because it's like you just follow a datasheet and add the pins and set them to proper type, and that's kind of it. Like it's a very relaxing thing. So this is out, this is in, DC is in, clock is in, CS is in, yep. So that concludes the right side. And then we connect all of these. How is the keyboard sound? Is it really loud when I type? I mean, I'm sure you can hear my mouse as well, but maybe it's not that bad. Oh yeah, way back I created a poll on Twitter asking people, should it be 0.1 UF or should it be 100 nano? And I know that's like tabs or spaces. And I think exactly like tabs and spaces, I think it was pretty much 50-50. There was no conclusion. And as you can see, I do 0.1 UF, and I don't really have a good reason for it because it's exactly the same number of symbols. Hey, Bleep Track. Congrats on getting your PhD. Well, starting your PhD. Very late, congrats, but I don't think you've been on my stream since then. So here we are. Then we can just do this. And do the same thing as with the backlight for the keyboard here. So I put this 10 ohm resistor here because the backlight is actually really bright by default. So if you don't use PVM, and this one, like you need to PVM from the main CPU for this. Oh, actually, that's another thing. Like, do I need a pin for this? Yeah, I'm just thinking because this pin should go to the feather again, but the feather will run out of pins before I can connect everything. So let's see. But it's really bright, and if you don't PVM, you just pull it high here, you're just blinded. So I put this here so you can have just a bit less by default. And 10 seem to work quite alright. It helps a bit. You can do like 20 or 100 even. Depends what you want as your default. So now I'm gonna be sneaky, and what I will do is I will just copy this whole block. And hopefully this saves me seconds. Yeah, and this still applies. And right, it's the same name. It's almost like I made this also. Like, it's just I'm repeating myself here. All right, then the IM, which is the interface select, or is it? I mean, it is, but I don't remember what IM stands for exactly. But this is the interface. So if it's 0111, that means in an SPI, which I think they call it 4-pin SPI, which means also the DC pin is there. So that's what we use here. You can configure this display also to be like 8-bit RGB or 16-bit RGB, or there's 3-bit SPI, so there is 9 bits in a byte kind of. So the first bit specifies if it's a data or a command. But I found this to work quite nicely, and as you can see, the Adafruit wing also does it, so we're good. We're in good company. And then these I don't quite remember. I think these are used, yeah, the pixel clock and the vertical horizontal sync are used for other interfaces. So I think the datasheet specifies, if not in use, pull them here. The left one is the new one. And I can understand your confusion because I'm just copying stuff. But I guess I can take a second to actually show the board I'm basing this on. Hopefully it doesn't explode, except it's not responding right now, but I can keep going here. So, yeah, let's add those. Yeah, I know that was wrong, so let's just keep going. Okay, that's all kinds of wrong. And that's also, that could have gone better. XP, YP, XM, YM. Right, so this is a note to self. And actually, yes, I need to put this note also on this board. Let me just already add it. Reason for this is, let me just add it. I can add it here, or I can copy. I like it actually. It used to be that Kicad didn't allow you to copy stuff between two instances, but now you can do it. So that's very nice. Like the clipboard was local to the instance. Okay, so the reason why it's important is because the keyboard has these snaps on the side, and if it's 1.6, they will not snap. It will just be too thick. See, so here's the board, and here we have these snaps, which I didn't quite model properly, but this is like one of my early Fusion models. It's still quite alright. So yeah, the snaps will not snap if it's 1.6. So that's why it's really important. And I learned this the hard way. So yeah, so this is the board that I was working on for like half a year. And the front will be pretty much exactly the same in the wing. So you have the display, and there is a poll on Twitter going on right now. Should it be centered on the active area here, or should it be centered on the board? And if you watched a stream of me ever, you'll know I really like things to be like centered and perfect. So it really itches me that it's off to the side, but I also enjoy that it's perfectly, active area is perfectly in the middle. So yeah, you take the good with the bad. And the poll right now, it's overwhelmingly like 95%, I think, that people say it should be like this, like it is here, that it should be centered to the active area, because once you have a case on it, you won't notice the LCD being offset. So yeah, and then you have the 5-way joystick here. That's also my model in Fusion. It's okay, I guess. And these two soft, like they're really nice buttons. They've gained some popularity recently. Like when I got them, they were, I'm sounding very hipster right now. Like I got them before they were cool. But if you try them, they're really nice. They're like soft. They don't click. They're just nice and soft. So they feel good when you press them with your thumbs. And yeah, then you have the Blackberry keyboard. And that's why I'm saying there is space here to have 4 buttons instead of 2, but I'm out of GPIO. So we'll see about that. And then on the back here, you have the 2P mods. And there's the LCD backlight, so we'll need that as well. The SD card. There was a Wi-Fi module here. Then I was using, as the main CPU, I was using the NRF52 module. I started with just the chip, but it's actually cheaper to buy the module than to buy the chip and all the not peripherals, the passives and crystals needed. Go figure, China. And yeah, there's the I2C keyboard driver, and yeah, I mean, this is really like it's self-documenting. And a Nokia battery with the connector. See, so I really like the position of this, and it was really nice to actually charge and connect. Like it felt good to hold it and just plug it from the bottom. You can't really have this. I guess or can you? You know what? You could have it. You just won't get the data, but you can connect the V-Bus. So you could charge it over this port, but wouldn't get access to the bootloader and all that. So that might be confusing to the user, and it's probably not worth putting a like $1 connector just for charging on the bottom. I'll think about it. Because if you have a case, then it would kind of be sucky to have the feather to the side. Now that I look at it, it might be still not enough space for the display connector. Maybe the feather could be this way here. I haven't thought about how exactly it's gonna be on the board. Like I thought it was gonna be this way here, along it, or what's the word? Not parallel, the other word. But maybe it should be parallel here and actually have the USB going up. Or maybe it could be here and then the battery up. But then the problem is when you hold the key by the keyboard, your fingers rest here. So you don't want your fingers to go on top of the spiky and edgy feather. So it's better to have the battery here because battery is nice and smooth, so your fingers can just go on top of it. So you preferably would want the feather here, but maybe I can actually have it here with the USB going out through the top, because the LCD will be, yeah, the LCD will be over here, then the connector will be maybe. But yeah, so this is how it looked, and this is how it will probably also look now with this one, just with a feather on the back. But getting back to reality, this is it indeed, right? So we can import this stuff over here. That's a lot of inputs. Was it G? Actually, I don't remember. Is there a shortcut for resize? There is not, and that sucks. I can go here for a cheat sheet. That does not really help. Oh yeah, I forgot forgot these guys over here. How are we? We've been streaming now 1 hour 20 minutes, not counting the previous stream. Yeah, I did way more in the hour 20 minutes than I did in the 40 minutes in the first stream. Like in the first stream, I managed to do this. That's it. It was just crashing so much. These are all outputs in a way. I mean, these are on a resistive touch, just analog values, but they are outputs, so that counts. Thanks, Bleep Track. I don't know if you already left because I lost one viewer, so maybe. But yep, good night. Thanks for stopping by. Oops, what did I do? Something. Data, and command. And then it's really funny that sometimes for Misomosi I actually have to say it out loud to know which one is which. So it's master out slave in. Yeah, that's the one I want here. Master in slave out, yeah. I can't possibly be the only one that has to say it out loud. So much space for activities here. So the keyboard, yeah, the LCD reset is done. Then we have the backlight. We have to deal with that at some point. Right. Need to resize this to import the touch. Over here. And I need to resize it a bit more, I think. Or maybe not. It's fine. This is not fine. There. XM PYM. Correct. Now I'm curious if Kicad has a symbol for that STMP. Okay, that's a different one. It's okay, we can do that later. I'm still on the fence if I want it. Right, so we have to go back here, and I said I will put the pull-ups on the CS inside. Now I'm not so sure anymore, especially since there's no inside for this. Yeah, you know what, let's... Nope. Yes. I thought it was crashing, but it just got slow. Okay, that works. Need to have them same size. Yeah, so this is gonna suck from just the way it shows here, but let's actually rearrange this. Since I have the control over, that's the wrong one. The footprint, can just fix it. Problem is, if I put CS pull up, it has to go way across all these, and I don't like to cross the lines like that. So we can do you know what, I'm actually... Are these also offset? No. Okay, so now to not screw this up, it goes like this. Correct. And then smooth sailing over here. Pull up, since CS is active, low. And here, not so much, not so easy. Oops, that's more than I wanted really. So let's just add it by hand. Yeah, since opening this choose symbol window takes more than 0 seconds, I usually copy symbols, as probably you noticed. It's usually faster, assuming I have the symbol somewhere close. Right. All right. That's pretty good, actually. Right, the symbol. So we still need the keyboard interrupt, possibly somewhere. Right. The pull-ups on the I2C. Yes, I decided to put them here. So we do that. Wait, how did this happen? Did I seriously just copy the 2 exactly wrong pins? There's no good way to do this nicely. So we have the pull-ups on the I2C, which I believe usually I put to 4.7. Correct. There is some math behind it that I never remember, but 4.7 has proven okay, so I use it. Right, there we go, that's quite alright, I think. Oh. How did this happen? Did I copy the wrong 2? I don't know. Never mind. It's done now. These are correct. 4.7, yep. So what is... Right, it's gonna ask me to annotate. So what is missing? All of this. Cool. Right, it's gonna complain. Oh, card mossy. Yeah. I forgot the SPI. All of it. All of the SPI. I can see here it's actually called SCK, so I might rename it also SCK. Just moving some stuff around over here. Right, so we have the SCK. So just to be consistent, let's rename all of these. Oh wait, this is ice cream. Oh, I think I'm tired a bit. Because this is ice cream, yep. This is ice cream, not the SPI. And I just did this. Correct. So that stays as DL, but this we can rename. See, this is my problem that I'm always having. Like, should I keep the names that are actually in the datasheet for this one, or should I keep it consistent in the whole datasheet, or in the whole schematic? So now, like this does not look so right. So if I do this, then it's gonna look a bit confusing here, especially with, see now here it's clock, so now we have 3 different names for exactly the same thing. Ah, this sucks. Right, so we have the detect also floating over here. Oh, I know what I did wrong. I know what those were. Those were the pins that are waiting for home, like GPIOs or something. Correct. We do the same 3 over here for the Misamasi. LCD DC is already taken care of. Yes. Now we can see it will still be a billion errors, yeah, because all of these are unused, so it is complaining about them. And also power flags are missing, so let's take care of those. Yeah, so if you haven't used Kicad before, you might find this strange that I have to add power flags, and what those are is it marks the voltage, like the power symbol, that it is powered not by anything on this board, so it's external power, which makes sense for, well, all of them over here. Also power, for some reason, it's a flag. So that means there's all the pins that will be connected to 3 volt are inputs, like there's no output for 3 volt, and the power flag marks it as an output, or it's marked as an output, and that way ERC can be happy that, okay, 3 volts does not come out of thin air, or if it does, you mark that you are aware of it. So basically it just tells Kicad to shut up. And yeah, when I started with Kicad, I found it a bit annoying. Like, why would I add extra fluff to my schematic just to make Kicad happy? But once I understood the reason behind it, I got okay with it. Oh no, it's not aligned. So yeah, so I usually just put them here in the corner so they don't bother anybody. So now a few errors will go away, but we still have all these pins that also, we have them, but they only appear once. Nothing is connected to them. So, I mean, that's pretty all right. So this is not perfect, at least right now, because they have the labels, but oh, what happened there? No, I moved it instead of copying it. Yes, they should shut up most errors. Yeah, right, and this is okay because these three here have nothing connected to them. Exactly, so that's all right. That is not all right. So here we put NC. Right. Oh yeah, that's also right, because that's just, it just means this one is not connected, but it propagates through this sheet inside. Yep. Yep. And 4. Okay, so that's it. So that's it on this side. So we only have non-connected. And they're all kind of optional. What can we do now? I could create this symbol quickly and connect it. That would be nice. Because for other things I need to do a bit of research on what is the feather way of doing these things. It's quite nice I don't need a booster for the backlight for this display. The one I'm using just takes 3 volt and is happy. That's really nice of it. Yeah, so we have the cards, the keyboard interrupted backlight. I guess for the back now it doesn't make sense. Yeah, what? It makes a tiny amount of sense. For the backlight, I could do an I2C PVM controller, so you could control the backlight of I2C. No extra pins needed, but that adds to the BOM, and that's no good. I want to keep this fairly cheap. I mean, I know it's gonna be a few monies, but if it was like 50 euro cents, that would be fine, but I'm not sure if that's gonna happen. Also, I'm not sure if that's gonna return too many results. Or too many, yeah, because right. Every MCU that has a I2C and PVM, it will show up here. But could we actually limit it? It's not really display driver now, is it? Lighting driver, because it doesn't output voltage. I just need the PVM. So where would it be? No. Switching LCD drivers. I'm actually not sure. Would it be in like an expander? Probably not. Ooh, what if the touchpad, the STM, what was it, something, that one had like 2 unused pins. What if they were PVM capable? That would be perfect. Actually, that might be good enough at least to turn the backlight on and off. Yes, that could work. See, like this one at least. If you can control this GPIO. Yeah, that could work. And if I could have this also, then I could have the car detect on it. Yeah, okay, STMP610. Let's have a look. From Adafruit, of course. And again, reading datasheets on stream, not the most fascinating, but it is a big part of the process. So 6 GPIOs, but I believe 2 of those are gonna be used for the touch. But that means we could actually use the other 2 for what we need. I believe that would be a very elegant solution, assuming it would work. And then we could probably just ignore the keyboard interrupt because, like I mentioned, it is optional. Could have it as a test point, and then if someone wants it, they could just solder a wire from the test point back into the feather. It could work. But yeah, that reminds me. How do I do it nicely? Because I want double headers. To show you what I mean. I want double headers like this. If I do this, there's no pretty way to connect it except like this, which seems not so good, especially for these symbols, except if I put them up. No, let's not do it like that. What if I add a double? But then I would have to do what? What is an elegant way to do that? And how does it not show actually on where is it? On this schematic here? Oh, I see. It's ×2. So this is a custom, yeah. I mean, it is a custom symbol. So every pin is twice. I might actually be something I have to do also. That would make my life the easiest. You know what, we'll do that in a second. Let's finish this. I'm really getting distracted. So, right, these 2 GPIOs, they seem to be, Adafruit seems to be using this one as, or is it? Are they using this as an input or an output? That's what I'm wondering. Because if this is an output, that means they could reset the board or... No, reset is there. That doesn't make sense. I'm confused. Right. So there's the touch. That's really nice. This is a really nice chip. Chip. Why have I not seen it before? I'm sorry, it is a bit late. what is this pin called over here? It's called into. Yeah, it's a GPIO. Cool. Oh, that's it. Yeah, I'm not 100% sure why that is connected. Yes, exactly. So I know EN is an input. But why would there be an input to... It's actually not connected to the enable. It's only connected. Okay. Okay. I got it now. It's not connected to the EN. It's connected to the button here. But this is effectively a backlight controller, which is exactly what I was thinking about doing. So if I wasn't so tired, maybe I would have figured out. So they do exactly what I was just saying I should do. They do backlight control using this as a GPIO expander, which is really nice. So let's do the same. Okay. Right, so to actually do that, I need the symbol. Oops, that shouldn't be here. Y1, actually, I might just copy from here, since like it has many pins can do two things, and I just wanted to do exactly this, so this works best. So let's check one more thing actually before we start. Which library should that go into? Interface expansion. Sure. We go into the... right, it's already open, which is even nicer because it takes some second to open. So I make a new library. Then it gets added to the project, and I can add it if I can find it. STMPE610. What I want to see is, because Adafruit symbols are, I mean, I don't want to badmouth them, but they have a tendency to put only partial name of the actual part. Okay, now this is very strange. STMPE6. Oh, was it 8? See, that's not right. Didn't I just find it? Or is this a different one? Because if it's not on Mouser, that's a bit of a bummer. Oh, you know what? This says 610 here, but then E811 here. That's why I got confused. Because I was fairly sure I found it before. This is why. So do they actually have the wrong... What did this datasheet say? Right. So the difference seems to be the number of GPIOs. Maybe this one is, no, I thought it was maybe fixed to be only SPI. What's the difference here? 1, 2, 3, 4, 5, 6. It has more GPIOs, but it has the same number of pins. Go figure. Okay, I will split it again. Right, so there's the NC, so that's 1 GPIO. And the other 0, 1, 2, 3, 0. All right, okay, I get it. So in the reset state it selects, but they just tie it. They just waste that 1 GPIO to always be set to whatever they want, which is fine. So this is actually why they don't use in3, is it? Or no? No, because that's here. So they could still use this one. I guess since they are the same footprint and pinout, they just can use them interchangeably. But since we have this one on Mouser, let's just use this one, right? Let's STM-PE. Yeah, those are the only two available. And the difference between these two, I bet, is tray and reel. That's more than it showed before. UTR. Oh, this one's actually totally different. Yeah, let's not spend too much time on this. This one is fine and it will work and we're good. So let's just go here. I will double check after I copy this that this is actually correct. But what I was saying is they're not so great at putting the full name of the part, because some parts come in multiple variants, which actually might even define the package used. So like QFP and QFN, and will be one letter in the name, but they will not put those letters at all, just the main part of that name. So I like to put the whole thing, because then you know in the BOM exactly what you have to order. So let's do that. But in this case, we can actually see QTR. Oh yeah, there. See, so this one comes only in 1. So I'm not sure what the other one was, but that means we can just do this. And now we can start creating these. Five. save out. So this is actually output. Input. Interrupt, which apparently it's not used. So I'm guessing this one also works in polling mode. 2. Okay, they call it plus and minus. It differs between things, between different chips and such. It was 0, I believe, wasn't it? Yes. See, so we have actually 3, and we need 3, so I could actually use all of them. That would be quite nice, actually. I'm curious, the interrupt or poll. No. How does it actually work? Let's just see how they do it. There. I mean, it obviously is polling because CircuitPython, again, as I mentioned before, does not support interrupts. So it has to be polling in some way. Exactly. So you just do read data. You can get the number of that. Yep. So we don't need that. We can put in a test point like they did. Starting to have too many browser windows open. We can create this. These two, that one on the bottom, this one here, BIOS. Yep, this will do. Yeah, there we go. What we can do is add a data sheet. We can assign a footprint already also. Makes it so much easier later. It was a QFN 3x3, was it? It's pretty tiny, yeah. So QFN 3x3 16. 16, 1 EP, 3x3, 0.5 pitch, correct. And right, the difference is only if it has the vias or not, and we don't want them. Right, there's also EP size variations. What do they recommend here? They're 1.8, so 1.75 should work. Yep, cool. And all right. So that takes care of that part. Can now go back here and add it. This worked out really nice, actually. STMP. Yeah, so this one, right, so the 8 in the number, right, yeah. Because before the first one was called 6 because it had 6 GPIOs. This one is 8 because it has 8, and there's a 16 as well. It all makes sense now. And yeah, I could submit this one to Kicad, but as you notice, my way is different than their way of arranging things, and I don't think they would accept mine, so that's why I don't do that. This doesn't align at all. Now it does. No decoupling on this. On this sheet. I don't know, I feel like I'm fairly fast in Kicad, which I really like. Right, so I might need, oh no, I did the pull, put the pull down, yeah. Although, one thing to consider here is what's the default for feathers or for wings on the backlight, because there's a pull up here. Does that mean the default is the backlight is on? Because if that is the case, then I would probably want mine to also be on, because that's what the users, what the people who use that board will expect. So let's actually check out this chip. Oh look, I looked at it at one point. shutdown, logic high enables, logic low disables. Yes, and this is pulled high by default. So the backlight is on by default. There you go. So I will change that to be consistent. Now, second thing is, do I also want the backlight on the keyboard on by default? And I would say no, because it's optional in the sense that you don't need it for the keyboard to work. For the LCD, you do. It won't work without it. I don't know where to put these things. Put them here for now. So let's go to the LCD, flip this, change the comment as well. I will do it. So now the backlight will be on by default. And on the detection, do we care also? Possibly not. Because should there be a pull up on it, since it goes down when there's a card inside? I would say no, because the user actively has to read it. So at that point, they should also put a pull up on it. That's what I would say here. Missed it. Right, just give me a second. All right, back to reality. So we have the interrupt on which we can put a test point. I think I will finish this and we can wrap up for today. It's almost midnight soon. That's actually pretty good progress. What do they call it? RT, which, what does that exactly stand for? What does it stand for? Touch screen, no. RT, no idea. I'm just gonna call it STM. Right, another thing that just came to that I just thought of is what size components should be on these boards if I want them for people to assemble, like 0603 I think should be fine. Like I would really rather not go 0805. mostly because most of my stock is in 0603 and 0402, so would rather not go there. I think that should be fine. STM CF. All right, I need I need to connect. What the heck did I do here? That is very wrong. To connect the CS for this one to some GPIO. So Mosses. And it's gonna be the exact same one as the one on the board on the right, which is GPIO 6. We can remove that and see. Let's see, we have like 15 minutes, and I think that's enough time to create a symbol for the feather actually. What? Did I screw up the symbol somehow? Number 3 is number 5. Okay, that's confusing. Right, this is not driven, and that's fine. I think I know what I did here. That these are supposed to be inputs here, but it doesn't explain the other error. Right, so that takes care of that. That's still an error. Let's read this. Pin 3 of U5 connected to pin 33 of U4, which is, this is 4. Right. Right, because they're both connected to Mossy. which is fine. But then why is it complaining? Why is it not complaining here? All right, because this is accuracy. Right. And then here, so what type does this say? Bidirectional. Yeah, I guess that will shut it up, which is not technically correct, but I might have to do it that way. That's the only one that needs this change. Yeah, so there's now only one mystery. What the heck do you mean by this? Oh. I see it. Spin one twice. So what should it be? This is y minus 1. So VCC is 6. See, I didn't do the class. I got too lazy. I should have checked here. Exact mistakes. This would have showed me that I have pinned 1 twice. Not good. Yeah. Yeah, that will shut up that error. Okay, so this is the only error, and I get it because this is power in and there's nothing driving it. So we go around that just by saying this is just an input, but that will also, oh no, that shouldn't need a NC on it because, yeah, so that shuts that up. Okay, so the feather, can we do it in 12 minutes? I think so. The only thing I need, right, because if I create a custom symbol, then I also need a custom footprint for it, and that's annoying. But I could create 2 symbols, the left and the right, and then they just connect to the one, to each footprint, to the standard footprint. And but maybe I want a custom footprint because then I can have the outline and a 3D model and all that. Yeah, okay, let's do a custom footprint symbol and footprint. So now what I'm wondering is what's the name of the library that should have this, and I think it's module, like Wemos. Is there a Wemos here? MCU module. Better? No. But that's right. That's not a. Wait, that is 2 is no 2 is a. Right, that's not a standard header feather. Okay, but it's MCU module. So go fast. And if I go fast, I make mistakes. So that's not great. I guess any feather. No, what's a good name? Because it's not a standard feather, it's the feather with the two sure. Okay. Hmm. 3, 16, 17, 28, and then it's probably 29, 30, 31. I would assume like that. So we have reset number 1. And that's an output. I guess it's bidirectional actually. Then yeah, this will take care of the flags also actually, I think, because it's gonna be a power output. So number 3 volt, number 2 power output. A0 on 5 bidirectional, and now we can take advantage. I had too many. She clock is output as well. And 14. They call it NC here, isn't it like another GPIO? Like I think it's a GPIO on the Hazai, or yeah, on the 32 I have here. Strange. 14 stir in input, and it's supposed to be 13. It's ground here, but not. Now let's keep it. Let's add it, but let's keep it a GPIO for now. So for 16, we have the, let's call it NC, but let's make it bi-directional. And then 17, no, SDA 17, SCL 18, output. That doesn't seem to check out. All right, because was too trigger happy. And that's a power output as well, 26. Okay. So what we can do now is we have to duplicate all of this somehow. Okay, but first, here was the split. Yeah, that worked. I don't think I can make it in 3 minutes, though. But it's not a hard deadline. So I can go a bit longer. So what I need now, actually, yeah. I need the names. Yeah, that's not gonna be so fun. Wow, that's actually useful. I need to make the copies passive so they don't start going crazy when I... Oh shit. I need to cancel because I didn't copy all of them. Because when I put it on top, if they're not passive, it will say there's conflicts and so on. Ah, this was going so well until it wasn't. Oh, that's the worst way this could have gone. I have no idea how it's sorted. I think it was by X, Y, Z. No, not Z. X, Y. So these are also slightly too long, I would say. Luckily, Kicad has this option, which is really nice. Right, no passive. No passive. And can I hide it from this dialog? No, doesn't look like. And I don't think I can hide it like this either. So that will take a second. I wonder if, I don't think, because PCB new has a Python console. I don't think it's available here, because then I could actually automate it, like iterate over all of them. If type is passive, set it to non-visible. It would probably take faster than doing this by hand. To be honest, it would make sense to have Python also here, because you could import like an array or a map and generate these so much faster. Or you could automate, because insert only allows you to like insert only works if both the GPIO number and the pin number increases. What if the GPIO increases but the pin decreases? Then you're screwed. But you could do that easily also with Python. Just generate all these pins. And if every other is like input, output, you could very easily do that as well. So it would allow you to do quite a lot actually. There we go. For whatever reason, the stacking here is, yeah, it is what it is. Now for my last trick, I need to decide how much detail do I want to put into this. Because you know how I was complaining about footprints that look physically like the things that they represent? It makes slightly sense here. It's just fun like this. Yeah, isn't that kind of cool? Maybe. Maybe not. Oh wait, I'm on the wrong grid. Right. So there you go. It makes it look silly when you do it. Also, it's not centered. Okay, so now it's centered, but there. The pins are correct and everything's good. Alright. Took slightly longer than expected, as usual. Damn, it ended up on the wrong grid. Of course. Then, exactly, now it's not. I shouldn't have started fiddling with the grid. Okay, so now they're equal. Yeah. That was silly. What does the ERC say now? Yeah, it says annotate me. No, that's wrong. That's gonna take a second. Okay, that was lucky. Although it takes a second still. Those are strange, but I get which was this? Power output is connected to 16. Right. Although it's showing here, but here I get this that it's possible it actually needs a flag. Nope. Okay, but let's skip that one for now. I'm just thinking, why would the no connects stop working? I mean, these labels. All right, yeah. Yeah, that's good actually. It won't complain. You know why? Because there's actually 2 pins on each now, like because of the connectors of the way I designed this. There's actually 2, so each of these are actually connected now to themselves, to their own passive clone. So let's see. So I would assume we get this in the middle. Then you can have the SD card. All of these shenanigans to the side here. Yeah, I think this is all right. Oh, did the stream having problems? No, I don't think so. Because here on okay, my has somehow fell behind my live stream. But we're good. So is this actually mostly it? Should we recap? On the front, we have the display, which we can control it over SPI. It has a touch that's actually connected to touch thing. Reset is connected to the global reset, and then the backlight is over that expander, and the backlight is on by default. Correct. Under the display, you have the 2 buttons and the joystick and the keyboard, and then the keyboard is I2C. Yes, there are pull-ups on it. Yes, the interrupt is actually connected to the expander. The reset is also on the main reset. And then internally, the backlight is, right, the backlight is over the I2C. Correct. Then we have the SD card, which I'm pondering if it should have some pull-ups on the SPI stuff. Maybe not. But it has a CS pull-up, so that's good. And then we have the global switch. Header with double headers. Because on the back, what's on the back? The card, yes. The feather, yes. And the battery, yes. Then you can disconnect pretty much everything. Yeah, because the Misomosi won't matter. There's no CS, so they should shut up. And each CS you can disconnect, and the DC. Yeah, you know that this might actually be kind of it if we don't put the SPI flash on it. So for my last trick, I would like to go here. When it loads, to assign, to like see how many parts do we actually have. Oh yeah, I know one more thing. Yes, someone requested, and it was a good request, NeoPixel, like a status LED up front. So I will put that one also, but for now, this is all the components. So here's all the caps. So 0603, the micro, whatever, these are all like, right, the solder bridges. I need to find a good one. Let's do like this. Yes. So here are our options with solder bridges. They're all bridged, so that's not good because not all of them should be always bridged. This one shouldn't be always, right? Also these names, that's right, that's wrong. These are all the same size pretty much, yeah, so it's only the shape really. Right, so let's go for these. And also let's rename them. Yeah, because I copied, but I didn't properly change their names. So this is STM. LCD, and that's LCD DC. Right, so we can go back here. This should be now updated. It might take a second. Or more. All right, I forgot it. It forgets. You don't save and change. Slightly annoying. So actually, instead of bridge, let's do jumper. Yeah, so these three should be rounded pad, bridge. Well, it's actually strange that this is covered. I would have not covered this. And then that one should be open. Hello. We're close, like getting closer to the end of the stream, but welcome, welcome. I am assigning some footprints here. For the resistors, it's all 0603 as well. Resistor SMD. For the switches, that's a separate module that I need to. Yeah, sorry, it's fairly late here. but I want to finish on this one. Test pads. There they are. Should we go for something like 2 or 2.5? Kind of hard to know exactly how much is it. Like, should I take a caliper? Sorry for the noise. Like 2.5 millimeter. That's not that big, to be honest, for a test point. Yeah, let's go for 3 then. And that's it for right now, I think. Or maybe the SAM. I can copy from the other one. This one. Yeah, there we go on that one. And I think that's actually it. Oh yeah, I need to select some switch for enabling some nice. I don't really have any like positional switches in my stock. Need to find something nice. Would work well here. And that's pretty much it, I believe. Okay, well, one more thing I can check. This one, is it? No, it's an extra, unless they added it. Where is it again? Here. So connector, no idea which one. Right, it's connector card. It is slow. Battery, no, right. Yeah, it's a very small selection of card holders in Kicad, so I drew myself yeah, I drew one myself. That's not the one. That's the one. So there we have it. If I don't add the SPI flash, then I think we are done here. Yeah. Cool then. Let's see, when can I finish the PCB? Not Thursday, not Friday, not the weekend. Friday, no, not Friday, Monday. So I guess Monday I will stream again and hopefully finish the PCB and actually order. I don't think, because I'm going next weekend, not this weekend, sorry, to Maker Faire Berlin. And I was hoping maybe I could get them in time and assemble like 1 or 5, but I don't think if I finish it Monday and order Monday, it won't come for Friday. I order from JLC PCBs from China, so it takes a bit to get there. They usually do them in like 24, 48 hours max, but then it takes 3 days to ship. So yeah. Dave, what? You've been here all along and you... Ah, damn you, sneaky Dave. Why didn't you say anything? I'm always looking for, people in the chat to kind of chat with me, so I'm not just droning on. Ah, just came, okay. I thought you've been here all this time. Yeah, what do you think? What else does this board need? It has an SD card, a display with touch, which is optional. Then it has the keyboard. And that's kind of it. It's surprisingly simple. But yeah, I don't know why I would want to add stuff to it just so it has more stuff. Like there's no point in just piling on stuff. Let's have a quick look at the BOM. Right, resistor, caps, resistor, that's just like nothing. Then the BSS, that's also nothing. Then headers, the SMD headers, I worry might be slightly expensive. I mean, just relatively speaking. Yeah, a shitty add-on. I guess I could have that. It doesn't really match the feather, but it might match more the actual, because it's almost like a badge. So maybe you want that. And there is I2C already, so just putting holes, you don't even have to mount a header. It's pretty much free. Oh yeah, I wanted to add the NeoPixel. I will just leave a note to myself. Yeah, okay. Right, that should do it. But yeah, otherwise, yeah, I need to find a switch like this that's like from the side, kind of protrudes to the side. So if there's a case, you can still nicely flip it. Dave, I think you had some switch on your PCB-less console hand portable thingy. I don't know, did that have a name? Yeah, NeoPixel for sure. Don't think I should put like audio or stuff on it. But yeah, if you look at this page here, there's a lot of wings. All right. Before I was looking at a single page, it was super long. All right, so that's the one I was basing on, exactly. So it's gonna be quite similar. I'm gonna use pretty much the same headers here. Right. None of that. I mean, having LED matrix on the back for no reason would be pretty cool, but that's not. Yeah. Right. Yeah, some people said a PMOD would be interesting. I think could be an option to have like a double P mod just on top. So if you had some P mods, you could connect them. And then if it's not connected, then the GPIOs are available. It's not, it doesn't cost anything except the header. Ooh, GPS wing. I think like this board I'm making has quite a lot of potential. Like if you slapped a feather and then this GPS wing on it, you could have actually use the display, to display some map with you on it, and you could search for locations or something like that. Especially if you use Grogard's Linux board, then you just run Linux on it, and then it's super easy to do all of that. Or even the Ethernet wing, if you had like a browser, you could use the display to browse with the with the keyboard for URLs, or RTC logger, so you could log data and also then browse the data on the display. Or you could use it for, if you connect thermocouples, for logging temperature or something similar. Yeah, the audio stuff is a bit tempting, just having, but it just adds to the bomb. A camera, like a front-facing camera for taking selfies with your feather wing. That just would be, yeah. Yeah, LoRa. Many like people are really into LoRa like these days. So you could put that also on the back there and just have LoRa for communication. Definitely doable. Yeah, I think that's it. I will post it on Twitter and ask people what other thing would they want on it. No point in me extending the stream. I need to cut some Z's anyway. Cool. So thanks for everybody for joining in and yeah, hanging out with me, watching me Kicad. Second feather port. Yeah, I'm not sure there's enough space for that actually, but I want to have it like this, so you can have access to the GPIOs, and you can always stack them, just keep stacking forever, like 100 boards on top of each other. So should be fine. Yeah. Thanks for watching and see you on the next stream. Bye.